Hey guys, welcome back to my YouTube channel. In this video, will be a start of a series of trigonometry. Trig. So just short form trig. So we'll be showing the basics of trigonometry. Trigonometry is just languages of angles, triangles, mainly right angle triangles. So we're looking at six ratios that you have to. It's like a building block to identify and prove trigonometry. I'm going to be using this series or in this playlist. So just follow me. They're just the basics so that if you understand this, you can build on it and just know with time. So, like I said, is language of angles, trigonometry. It's a language of angles, by the way. So, right angle triangle. So, if I have a right angle triangle this way, like this, then the right angle triangle has a one side of it to be 90 degrees, and one of the sides is like this, theta, right? You can also, it does not have to necessarily be like this, but most of the times they look like this. You can also have something like this, as long one of the sides is a right angle triangle, and you have one of the sides like this. So any of the sides facing an angle, a particular angle, is the opposite. That is the opposite of. It's called the opposite. Why the angle? Why the angle? What it rests on, like the opposite of the adjacent of the angle is adjacent, while the opposite to the right angle triangle is the longest side of this triangle, that's the hypotenuse. So that's also identify. But in a situation whereby you have another angle, let's say for y now, it will be a different case. This will not be the opposite, this will be the adjacent. This is will still be hypotenuse. Hypotenuse don't change, it's only opposite and adjacent that change with them. With the depending on the angle. So in this angle, we're only dealing with this. So we're looking at different ratios of, there are mainly six ratios, but there are two on which all of them are built on. Then the first ratio is sine, and since we are using this angle, since these are opposite and adjacent and hypotenuse, beside theta is defined as opposite over adjacent, sorry, opposite over hypotenuse, opposite over the hypotenuse. I'll just write the short form image, right? Then we have the cosine theta. We have the adjacent over the hypotenuse, right? Then when you come, and these are the two major ratios that others are built on, but the top three is included tangent theta, which is also known as this tan theta, which is the opposite over the adjacent, right? And this is most commonly known as SOHCAHTOA. SOHCAHTOA. So the idea is just sine theta. The first represent the trigonometry. Sine theta opposite then hypotenuse. Since we know it's a ratio, they are all ratios. Just write trig ratios. So cosine over adjacent, that's adjacent hypotenuse. So this one is opposite and adjacent. It's very popular. And tan theta can also is mainly represented by, this is just the final result. Is mainly, since I said every other trigonometry is built on these two. So tan theta, the short form for tangent theta, is actually sine, or the short form for sine theta, and cos theta is actually this ratio of these two, and which if you use this now, opposite sine theta, as opposite by hypotenuse divided by this, right? And when you divide it, you ratio fraction, you swap, you have to flip it. You have hypotenuse over adjacent. So these are the strike route. So you have which is same as this. So that's just like it's from sine and cosine. As I said, is the these are the two uh major ratios whereby you can get other ratios from, right? So going forward, there are other three ratios, but they are mainly reciprocals of most of these. Some reciprocals that are reciprocals ratios. That is, they are one all over. That is, they are one all over this, like one over this. So the first one is cosec cant. You can also call short form as cosec theta, which is just basically one over of the sine. Okay, that's the sine theta, right? So when you have one over sine theta, just like one over the opposite of this, that is one over when you have 2 over 3, 1 over 2 over 3 is 3 over 2. So we have now, so opposite over hypotenuse, so now be hypotenuse over the opposite. So just a reciprocal. That's a cosec theta. Then we have the secant theta. Techniques, we have to know each of these, like get familiar with them so that we can make use of them eventually. And this can be a little bit tricky because this cosec theta is relating to cosec, but it's actually relating to sine. That's like a trick part of it, and actually confuses me as well. So why the secant theta is 1 over cos theta? So taking note of those things, something you can actually just grab. So 1 over cos theta just be 1 all over adjacent over hypotenuse. So that will be the opposite again. I have hypotenuse over adjacent. Right. Then the last one is the cotangent. That's cot. That is just basically 1 over tan theta as well. So what's 1 over tan theta? Just be adjacent over the opposite. That is the denominator coming up to be the numerator. Wow. Like we also arrange this that could be arranged by sin theta. Cotangent theta as well. Sorry, cotangent or cotangent theta. I think I'll prefer that one. Can instead of writing this way, you can go the route of writing it cos theta over sin theta. Yeah, you can read it like this way. That will give us the opposite, and you still have to have adjacent over hypotenuse. So this they are the common one we need to know to prove or to solve any trigonometric questions. So we have to know all this. In the next video, I'll be showing you on how since we're going to be doing a series of proving how sine theta plus cos theta is equals to 1. Do what to check the next video. Thank you very, very much. This is my next video. And before that, I'll be showing you how to use this in a question, like raise a question and apply it so it don't look so abstract to us. And afterwards, we'll do this.